Okay, so now that's the question that we have. So now, how do you go about this particular question? So again, identities are very important. That's why you might recall I said last time that that's why I ensure that before we started the calculation, we started the function, we go through the identities. So we're going to find the values for this with our range being what? Being 0 to pi. I want us to get used to switching between degrees and radians because some people tend to be, I don't know why, but there's just some fear that is attached with radians. Yeah, so there's just some fear that is at, that is attached with radians. So that's why I want to be interchanging them so that people are comfortable with both. So then what you're then going to have is, so what what identity are we going to use? So the identity we are going to use is cos. We're going to use a double angle formula for cos 2x. That's a double angle formula. And then what then we are going to do is we are going to write the what? The substitution for the what? For the double angle formula. Okay. So I don't know if I can derive it, but for the interest of time, you can verify this. You can verify this, but we did it. You can check the other videos. So what you're going to get is that and that, and then this you can either substitute in these to get either this, or you can actually also find the what. So that's the thing. So meaning all these you can use them. Now, which one are you going to use in this particular case? So what you are trying to look at is you are trying to look at what you are having here. So if for instance, if where we have here we had sine, meaning in that case we could have gone for what? For this equation so that we can have what? So that we can have a quadratic equation that then we can be able to what? Which we can be able to solve, and we can be able to answer it like that. But because we've got the cos here, so it means that it will be easy for us to what? To use this format of this equation. So again, if you didn't know this identity, then you would be stuck. So that's why revise the identities, go through the identities, ensure that you are comfortable with them. Okay, so that's about it. So now let's now substitute. So what we're going to have is, so that's that, right? And then we write the cos x there. Then again, remember what we said yesterday is that don't always want to be quick to divide both sides by cos because you may lose some answers, okay? So what you want to do in this case is just bring this cos this side, okay? So let's do just that. So then what then do you do in this case? So you just treat it as a normal quadratic equation where you can want to picture this the same as what? The same as 2x squared uh, x then minus 1, right? So that's basically how you can look at it, just to simplify it. So now how then are you going to factor it? So how you factor it is you want to your product, which two numbers are going to give you a product of minus 2 and then the sum is -1. So those numbers are going to be -2 and what? And 1. Because when you multiply -2 times +1, you are getting -2. And when you add them, you're getting negative what? -1. So that's basically how we go about these things, right? So having done that, what then we're going to do is then just substitute. So then what you are going to do is, remember you want what? Oh, sorry. I've made a mistake. It has to be a positive here, right? Yeah, okay, great. So here we're going to get +1. Okay, so let's just rub this on this side. So you're going to have cos x -1. Then you just equate either. Okay, so we just do that. Okay, so let's now get for the other one, the other part. So can someone tell us what okay, anyway, can someone what tell us what x is going to be if cos x is equal to 1? Okay, so x is going to be 0, and then it can also be 2 pi. Okay, so those are the values, but remember the range which they've given us, right? Look at the range here on top. You see that it does not include the what? It does not include 2 pi, because on the 2 pi, it's not a curly bracket, it's a parenthesis. So meaning we just want angles pretty much which are going to be you could say it should be less than that, but for the zero, oh sorry, for the, I made a mistake with the with this. For the zero, it's actually that. Okay, yeah, so you see we are saying we want something that is what, the zero can be an answer, but the 2 pi in this case, because of the range that, or because of the domain that we've been given, so we only get 0. But if the domain was, which was actually say, and it was a curly bracket on the 2 pi, then 2 pi would have been the answer as well. So the reason why I've just chosen to add that thing is so that we could see just how important, always looking at your range is, so based on our range, so we're only going to get x to be equal to 0 because of this range, which is saying we are getting some, we are, so it's our range is equal or greater to 0 but less than what, 2 pi. So we can't put 2 pi because it's saying what, less than, so these are some things which people miss out, and they're wondering why they didn't get the full marks, because just this understanding alone, you can even find that this one has got a mark, maybe even 2 marks, because you've understood and you've taken note of the fact that you've taken note of what your range and your domain is. So now, what's negative half? So then, for this kind of question, then you're going to say, what is going to be this? X is going to be what? So what you have to think about is, forget about the negative for now, right? And say, what, let's say cos x is equals to half. So forget about the negative for now. Just focus on the what? Just focus on the positive. What is cos x is equals to half? That gives you what? 60, isn't it? And so 60, we write it as what? We write it as 3, isn't it? Pi over 3, isn't it? Yes, that's it, right? So, but this is not our answer. Do you know why? Again, we go back to this. All students take coffee. All students take coffee. So, if all students take coffee, then what does this tell us? So, this tells us that cos is negative. So, meaning cos is what? Cos is in the third and second quadrant, because this 60 here, this pi over 3, that's 60, that's in the third, that's in the first quadrant. So we can't say x is equals to that, because our cos would have been what, would have been positive, right? Because that's a what, that's in the that's in the, that would have been in the first quadrant. So then we want answers which are going to be where? Which are going to be in the second and third quadrant. So we know how we get this. So we say it's pi plus this one that we found, right? So we say 3, then here you're going to say 3 pi, then pi, then 4 pi over 3, isn't it? So that's 4 pi over 3. So that's going to be your answer. Then the other one that you want then to get is what? You also want to get now the one which is going to be in the, oh, sorry. This is for the, third quadrant. Pardon me. This is for the third quadrant, because the third quadrant is where you add 180 degrees or pi to your answer. That's for the third quadrant. For the second quadrant, you actually subtract your angle from what? You subtract your angle from 180. Yeah, sorry about that. So 3, then there's going to be 3. So there's going to be 3 pi, then there it's going to be 3, then it's going to be pi, so here it's going to be 2 pi over 3. Yeah, so this is our answer in the what, in the second quadrant. Yeah, so I made a mistake there. So anyway, I've corrected by the right things I've put, right? So this is for the first one for the second quadrant, and for, sorry, the first one for the third quadrant, then the second one for the second quadrant, right? So meaning that our values of x then are what? So we'll start with the smaller one. Okay, that, yeah, what, it just looks neater. Yeah. So so then you've what? Then you've answered. So the key thing why I loved this question is because it oh, and then our other answer here, right? Let's not forget of it. So the reason why I really liked this question is that it brings a lot of aspect on the what? It brings a lot of insight on the what's this on the on those things. So I think having done that, I think that's pretty much enough on this. So I think we can be able to proceed and look at limits. So limits, if you want to say limits is actually we've actually started calculus. Okay, because limits are basically introduction to what? Are basically introduction to calculus. Okay, so basically what you're trying to find out in limits is you're trying to say and you're trying to reason and say, okay, this particular this particular equation that I have, what would happen as the values of x are going towards a particular number. So let's put, for instance, I say there is this function, right? Let's say, okay, so let's say there is this, limit as the values of x approach 4 of a function f of x. So I've just put f of x so that it can be any function. So what's happening there? So what you're basically saying on the limits is saying what value will this function have as my values of x approach 4. Okay, so for certain functions you're going to find that it's going to be easy because you can easily substitute these 4 into the function. Okay, for instance, let's say if my function, right, if this f of x, let's say limit is limit, so what will be my value when my x value goes to 4? So and they are going to have 2x. So what's going to happen? You're just going to say, okay, this means when my value of x is 4, this equation is going to have a value of what? It's going to have a value of it's going to have a value of 8. Now, why is this interesting? This looks easy for this one because it's a simple function, right? But this is important for your understanding because then you see that you're just basically trying to say what value is my function going to have as the x values are approaching what? As my x values are approaching, as my x values are approaching 4. So that's an important point to take note of. Okay. So now having done that, then what you want to then do is that you then want to look at then another example. So then this is very very important to take note of. Okay, so don't know, I think it has stopped sharing. So let me stop the sharing and then I will continue. Yeah, so the part that is interesting and that's important, so that's basically about the what, about the limits. But then we are going to have certain cases where the question that you are dealing with, okay, the question that you are dealing with, maybe it's got a fraction. And what's happening for that fraction, that when you plug in the value for which you want to find the limit, you're actually getting the denominator being a 0. And you know that when you get the denominator being having a 0, it's an undefined thing, isn't it? So because it's an undefined thing, what then you have to do, or what then you have to use in this particular case, is that you have to do some some you know, you have to do some manipulations, okay, for you to be able to answer that. So that's what we are going to look at. But I hope you've understood the concept of limits. Okay. So now let's now look at a real example. That one was just part of the explanation. Okay. So then, what then you're asking yourself is, we are saying what will be the value of this function x squared minus 4 over x minus 2. So then what then you're going to ask yourself is that, okay, so for this particular equation, then you're going to say what's going to happen if the function goes where, goes towards what, goes towards 2. Now when you substitute, when you try to do the direct substitution, you are getting, that's 0 over 0. Now you can't solve that, right? So what then are you going to do? From our understanding of limits, you know that what you're just basically trying to find is what value, what value will my function be having when x is going towards what, when x is going towards 2. So then for this one though, this one sometimes you might hardly be given this, but yeah, but sometimes you may be given this, since the manipulations are not really hard. But I just want you to get the concept, okay? Just get the concept behind the limits, okay? So now what are you going to do? Then you're going to say, okay, let me put a number in this function which is close to 2 and see what value this function is going to have. So I'm going to get a number which is close to 2. So let me say, okay, I'm going to get, let me say 2.1, or if you want you could say 1.9, okay? But again, our denominator is going to be a negative number. But anyway, but the point is that you use a number that is what, that is close to what, that is close to 2. So then we say, okay, we're going to use 2.1. So we're going to say in this function we put 2.1. So we have 2.1 that, then we have that, then that, then that. So what do we have? So these are things that you can easily manipulate. So yeah, you could be given a question like this. So you see, right? So you see, okay, so that's the value that this function is going to have, just above 2, right? So then you're saying, okay, let me try now to get as close to 2 as possible by factoring in 2.01, and let me see what value this function is going to have. So then you say 2.01 squared that over 2.01 minus 2. So we are going to have, okay, let's just for the sake of time, so it's just going to be what, 4.01. So you see, what really you can't deny is happening in this function is that the number is going to have 4, it's going to be approaching towards 4. So what then do you do? Okay, so what then, meaning your limit is what, your limit is 4. Because why are we saying your limit is 4? Because here's the thing, look at it. When we, it means that at 2, when we take this limit, when we take this function to 2, we see at 2 we can't really do it, right? But when we go a little bit just beyond 2, we see that this function is 4.1. Okay, when we go 0.1 past what, past 2, and then when we plug in 2.01, we're now getting closer to 2 again, right? So we see we're getting 4.01. What does that tell us? That tells us that, meaning that at 2, even though we can't compute this, but it just tells us that at that particular point, our graph is probably going to be very close to 4. So we can say our limit is what? Is 4. Okay? Because these two things are converging. You see, these two numbers are what? They are converging. In short, they are coming towards what? They are converging to what number? They are converging to 4. Converging simply meaning that they are meeting, they are all pointing to what? To 4. So now the thing is that, again, that's one way in which you can do it, but then there are also other techniques which you can use, because again, you may agree with me that this uh you may agree with me that this procedure that we've done is a little bit too much, you might say, and so you may want to use something that may be what? That may be shorter. So then you can use something, and that's what to look at. So now the same question: what's the limit of this function when x goes to 2? So it's x squared minus 4, then x minus 2. So then what then can you do? So you know the same problem, if we try to factor in 2, we are going to get an undefined thing, right? So what you're going to do is you can choose to what? You can choose to expand this or factorize it, factorization. So you know you remember this as a difference of two squares. So that's a difference of two squares. That's a what? That's difference of two squares. Okay. So let me uh, write limit here so that we don't forget that we are finding the limit. So then we are going to have that over, then what then are we going to have? Then we're having limit, so we cancel that. So then you can now plug in 2. So you say 2 plus 2, 4. So you see, we get the same answer that we have, but in this way you see that it's pretty much easier, isn't it? So let's now look at another example. So the key point for this is look at the question and see really what in what way can you be able to manipulate this particular question. So then you are going to have, so you have that. Okay, so now how do you find the limit when this goes towards what? When this goes towards 5. When this function goes towards 5. So for this one, you look at, do you have any denominator? Do you have anything? Nothing. So meaning for this one is you just plug in the this value 5. Huh? So yeah, so that's pretty much about it. So the reason why I wanted to put this question is so that you should be open-minded, and so that you can also be able to realize that some questions they will not be very very clinical, and some questions they will be more clinical. So all what is important is to look at it and say, okay, what am I trying to say when I'm talking about limits? I'm simply trying to find what value this particular function is going to have when x approaches what? When x approaches this particular value. And for this function itself, you can just simply plug in 5 there, and you get what the value that this particular function is what is going to have. So that's something that's important to take note of. So now let's now look at another example, and then we can just see how we can be able to appreciate these concepts. So we're saying, so we have, so limit x to 3, then so there x minus 3. So again, you see that for this question again, we are having the same scenario that we had for the previous situation, where when we plug in the 3, we see that what we are going to have is we are going to have the denominator with a 0. So then what do you do here? Again, you want to factorize. Now, one thing that you will see that this is the difference of what? The one that's the numerator. It's a difference of cubes, right? And how I want you to look at it is this. So, uh, let's say a cubed, b cubed. So your a is your x, then b is 3, okay? Then, of course, if you want, use uh, you can use what binomial expansion to be able to do this expansion. No, sorry, no, not binomial expansion. You can use the factoring of polynomials to actually be able to do this. But this is very helpful when you want to quickly find it. But of course, you can also do the you can use the polynomials to be able to find um, what these things are going to be after you've after you factored in there was this after you factored in the denominator, because here is what x is 3. When you plug in 3 in here in the numerator, it's going to be 0, and that's the definition of a factor, isn't it? So meaning you know that okay, you can factor that one in there. Okay, so that's just a quick way of you dealing with this. So then you're going to have b squared. Okay, so then you're going to have b squared. So I know I've really been talking for quite some time, but are there any questions up to this point? Are there any questions up to this point? Okay, so if there are no questions, then we can proceed. I just wanted to ensure that everyone was comfortable and following through. So then, uh, what then we do is we know that our a is what? A is x. We know that b is 3. So we're just going to substitute all those things into this equation that we've written here, right? This is just simply factoring. We just factorized, okay? Okay, so of course I said you could also use the principles that we discussed where in on polynomials. So how do you write this then? So you're going to say limit is going to be 3 x goes to 3. Then you're going to say, so again, what do you do? A is what? Let's say A is x, B is 3. So we just, that's x, that's 3. Then that's x squared, right? Then that's b and x. So that's 3x. Then that's b squared. So that's going to be 9, isn't it? So that's about it. Then, of course, we know that the denominator remains. The denominator remains. So then, here now, you see that pretty much the hard work has been done. All that is remaining is just to plug in the what? The value. So here you cancel that, you cancel that. Then you're now going to say limit. Okay, so you're now going to say limit for that. So limit this function as x goes to 3 is going to be x squared plus 3x plus 9. And then you're going to say, since this one is not quite direct, then you just plug in the 3. So that's 9 plus 9 plus 9. That's 27. So that's 27, right? So meaning when this function goes near 3 or begins to approach 3, the value that it's going to have is going to be what? Is going to be uh, 27. Okay, so let's continue doing examples. So yes, a minus b in brackets, a minus b in brackets. Yeah, you could do. Okay, so you're saying, can it be written like that and like that? Okay, yeah, cause okay, let's leave this one the way it is, right? And then let's just do with this one, right? We have put the star. So what are we going to have? We are going to have a squared. Then we are going to have mm, negative. We're going to have what? Negative ab. So we're going to have negative ab. Then negative ab. So we're going to have negative ab, isn't it? Negative ab. Then we're going to have uh, negative ab, and then you're going to have b squared. Well, okay, let's do it again. Let's write it. Then you're going to have a squared minus 2ab b squared. Okay, so then you're asking to say, can we write it like that? Well, what I would say is that, of course, there appears to be quite a small amount of difference between the two. But what I would say is that, yeah, so you could use that generalized one, or if you wanted, So meaning the one that I wrote on top, because you've seen that uh, this is not. But again, I think that's a very very interesting question that you brought about. But again, what we would say is ideally these two should have been able to what should have been able to. But remember, what we are looking at is this. Let me write this. This would have been true. You've seen what we've written. This would have been true if it was a minus b to power 3. Okay? But what we are having here is what? What we are having here is what? Is a power 3 and b power 3. Maybe that does not look different, but let me use this using another example. This is like having a like that. You get my point, right? It's going to be what? It's going to be a squared minus 2ab and b squared, isn't it? But then if I have a squared and minus b squared, you see that for this one, what I'm actually getting is a what? Is a difference of two squares. And what the difference of two squares does is, when I try to expand it, what I'm going to get is, I just want to clarify this because it's a very very valid question. So you're going to get what? X squared. Then you're going to get that's going to be a plus b. Then you're going to get that. Then you're going to get minus b squared. Then you're going to get what? A squared. Then it becomes 0, right? They cancel. So you get my point, right? So these two things are two different. The same way these things are different. You've gotten my point, right? Hello, the one that asked. Okay, yeah. So that's why you can't really. Okay, yeah. Okay, welcome. Yeah. So that's why you can't really write them like that because the concepts are different. Huh? Because the concepts are different. Okay. Yeah, but that's a very very good question. Yeah, that's a very very good question. So having done that, in the 9 minutes that are remaining, let's look at another example. Yeah, on this then. Uh, okay, let's see what we can do in this. So we're going to have trying to write 3. Okay, 1 over 3. Sorry, 1 over x over x over 3. Okay, so that's the equation there. So the numerator is that, the denominator is that. So again, so you see again here we are having the same situation. As you may see that if we try to plug in our 3 from the denominator, we're going to have something that is undefined. So then what do we do? So we have to manipulate this. Now how do we manipulate it? So what you do for this question is you want to find the common denominator for the what? The common denominator for the numerator. You see that, you see those, huh? Like they are having different denominators. So you want to create a common denominator for what? For these. So what you're going to do is limit, then we are going to have that. So how do we create that? Let me just write it here. So we're just going to say that. Then the common denominator will be 3x. Then this is going to be 3. Then this is going to be x, isn't it? So meaning you are going to have 3 minus x over 3x, isn't it? Or over. Remember, this is still the numerator. Don't confuse it. Then, once you reach at this point, you then want to get rid of the what? You then want to get rid of this denominator. Because one thing that you may have realized is the this numerator here and the denominator here, they are quite similar. And they are quite similar in the sense that for you to convert the one that is on top, it's just the same as multiplying by negative the denominator, isn't it? So what you're going to do in this particular case, then you want to multiply through by what? By the denominator of the numerator. I hope that makes sense, right? So we want to multiply through by that. So then what we're going to do is, so we're going to multiply through. So we're going to say 3x. Again, since you remember, if you don't want the value of a function to change, is the rule is what you do on the left, do it on the right, or what you do on the top, do it on the bottom. That way, you don't change the what? You don't change the value of the function. So that's pretty much what we are doing. So we've done that on both sides, so nothing has changed. To picture this is this. If we've got 1 over 2, if I multiply both this and that by 3, what am I getting? I'm getting 3 over 6. So the value hasn't changed, isn't it? So that's the reasoning behind it. So we now gotten rid of, oh, okay, that wasn't supposed to happen. So we've gotten rid of that and that. So then what we are having then is limit when x approaches 3 is what? Is 3 minus x over x minus 3. So then you see again, like I said, these two things are relatively similar, very similar, because what's on top is the same as what? It's the same as the numerator, it's the same as the denominator, just multiplied what? Just multiplied through by what? Multiplied through by -1, isn't it? So then what you're going to do is, we are then going to rewrite the numerator. Okay. Oh, sorry. I forgot the 3x. The 3x here, right? Yeah. This 3x, since we're multiplying that. So then what you're going to have is, limit when x approaches 3 for this function, so -1, then it's going to be that. Then you've got 3x over x minus 3. Then you've got that and that. So this means limit when x goes to 3 is going to be what? -1 over 3x. And then here you can then substitute now. So -1 over 3 and that. So you are going to have what? -1 over 9. So that's how you can handle these questions. So the key thing with these questions is about building it's about building on the concepts and then just letting the mathematics guide. Just letting the mathematics guide, because sometimes when you just look at it, sometimes it can look something like overwhelming. So that's about it. Okay, so that's about it. So then let's now look at the questions where we now have got a square root in what we are trying to find the limit for. Okay, so what we are going to get is, if we've got limit as x approaches 9, and then we have x there. Then take note that the negative 3 is not under the square root. Then we've got uh, x minus 9. So how do you go about this question? So again, the idea the idea for these, of course, we know that we can't plug in 9 because the denominator is going to be 0, and so the function is going to be undefined. So what you do, working with square roots and everything can be tricky. So what you do is you want to use the conjugate. Okay, so you want to multiply this numerator, the one which has got the what, the one which has got the square root, you want to what, to multiply it by the conjugate. Okay, so what are we going to do then? So what you are then going to do is you're going to multiply again. Remember, like we did in the earlier question, if you want to maintain the value of the function, what you do on the numerator, what you do on top, you do it on the bottom. So multiplying by the conjugate of the one that has got the side. So know that the conjugate is just where we have, where there was negative there. Oh, sorry, I've made a mistake. So where there was a negative there, I put a positive here, and then we do the same for the bottom part. So that's about that. So once we reach here, we then say, so then since we've already done sides, so I'll just run through this, right? So you know how you do it. It's this term with that term, this term with that term, this term with that term. So just like that, right? In a stepwise manner. So in a stepwise manner. So then what we're going to have, so what we're going to have is, okay, I know we've run out of time, but let's just do this quickly. Let's just do this quickly. So we're going to have x, and we're going to have 3, that, then we're going to have, then we're going to have that, then for this one, because this one is very very complex, so for now we let the uh, denominator be and see how we can manipulate it better later on. So then after this, then we are going to say limit as x goes towards 9. So then what you're going to see, so you see that this cancels, right? Because that's the same as difference of two squares, isn't it? When you are multiplying something by its conjugate. So what you're going to have is x minus 9, and then there is going to be 9 minus 1. Oh, sorry, x is equal to x minus 9, sorry, pardon me. Then there you are going to have that, and you have that. So then what then do you do? So there you're going to do, so that cancels that. Okay, so having done that, so then we want to, and let's now write what we are remaining with. So what we are remaining with is limit when x goes towards 9, it's what, of course here it's 1, we're remaining with 1 over that, isn't it? So we then, since this one we can plug 9 without getting any difficulties there, so we plug in 9 into this, so we're going to have 1 over square root of 9 plus 3. So we're going to have 1. Square root of 9 is going to be 3. Then that is 3 plus 3. then your answer is going to be 1 over 6. So pretty much that's about how you can go about these questions. So next time we'll just wind up on this, and then we can start there. We can be able to start the continuity.